Hey everybody, in this video we are going to continue with solving exponential equations, and we will be using natural log, and we will be seeing now what happens when you take the natural log solving an exponential equation where the base is the constant Euler's number e, and we will talk about the exact solution versus the approximate solution. So let's go into this quickly. The first thing you want to do in solving an exponential equation is you need to isolate the exponential portion. You need to isolate the b to the x portion. That means that 40 has got to go and the 3 has got to go. We normally talk about order of operations, but that's the order you evaluate something in. When you're isolating something, it usually ends up being the reversal. So what I'm going to do is I'm going to add 3 to both sides. So that gives me 40e to the 0.6x is equal to 240. Then I'm going to divide both sides by 40. Here, the 40 over 40 becomes 1. Here, I'm really getting rid of 10 on top and bottom. 24 over 4 is 6. So I can have e to the 0.6x. I'm going to leave a little bit of room, and it equals 6. Now I want to get my x alone. This is in an exponent. The inverse of an exponential is logarithm, and we're going to use natural log like we talked about in the last example. Now this works best with e, better than what it did in the last example, because of a couple of things here. Well, for starters, we could still bring that power out front because it is log base e, and power property tells us our exponent can come out front. So 0.6x. Now it's being multiplied, it's over here out front, by ln of e. Log base e of e is saying e to what power is e? Well, that means this whole thing right there is equal to 1. That equals 1. And 1 times anything is just that thing, because 1 is the multiplicative identity. So you have 0.6x equals ln of 6. Now something else I like to do is when I have a decimal like 0.6, which is 6/10, I tend to change it into a fraction. So I'm going to write it as 3/5 x equals ln, or natural log of 6. And the last thing to get x alone is I'm going to multiply both sides by 5/3, the reciprocal, because that ensures that the x is totally isolated. So x equals 5 over 3 times natural log of 6. This is actually the same as x equals, I could also write it as 5 natural log 6 over 3. Oops, a little cut off here. Let's see what I could do here. Can I squeeze a little bit more? Yeah, there you go. There you go, squeezing it in, okay? So there you have it. Both of those answers are acceptable, but if you wanted to type this in the calculator, you want to make sure you're getting an accurate solution, right? So let's take a second and actually push this into the iPhone calculator. Just I'm on an iPad right now, so we can see if our answer makes sense or not. Or not that it makes sense. We can't really. It's not that easy to tell there. But let's go ahead and put it in the calculator. 5/3 times ln 6. So clearing out my calculator. 6 natural log of 6. Enter. And then I'm going to do times 5. Enter, divided by 3, enter. I tend to avoid getting fractions in places if I can. Sorry, the calculator's will cut off, I'm a little zoomed in. But my decimal approximation is 2.986. I forget what decimal place is set to round. 2.9862. I probably could have copied and pasted it as well. To hundredths place. So that would be, where was I? 2.986. So the hundredths place is right there. So my approximate answer, oh, you can't see where I'm writing, can you? Hello. So approximately 2.99, because there was a 986. So there is my hundredths place. That's 2 decimal places. And that's it. Oh, I could actually, there we go. All right, so that is the end of that example, and I can do one more for us. And actually, let me circle. So, oop, that is too thick. Hold on. I have this and this are examples of exact solution, and then up here is my approximate. Okay, so here we're going to do the same thing. I'm going to start by adding that 5 to the other side. So that means I have 7e to the 2x, 7 being multiplied, and it's not being raised to the power. We'll be able to divide that in a second, is equal to 63. If I divide by 7, I have e to the 2x equals 9. Then I'm going to go ahead and take the natural log of both sides. So I'll have ln on both sides. Ln of 9, I can't really do much with it. Ln of e is 1, and the 2x that came out front is now sitting out front. So 2x equals ln 9. That means x equals 1/2 of the natural log of 9. That right there, probably too low again, huh? Sorry guys. X equals 1/2 natural log of 9. So that right there is an exact solution. 1/2 natural log of 9. And if I go and take a peek at the calculator, 9 natural log, enter, divided by 2 is 1.09. Okay, for rounding to the hundredths place, you write that as 1.10, 1.10, right? 1.10. So my approximate solution is 1.10. There you have it. That is the end of that example. In the next one, I will be solving quite a popular one that people always have questions on. When you have something, basically a base to a power on both sides, and you're going to have to bring the powers out front on both sides. So what does that look like? I'll give you a little sneak preview. I'm just going to erase a bit of this. This is what you're going to see in the next video right coming up. And then after example 4 of that style of example, we will see something like these. Ooh, so that's what's to come. So if you like what's in the on deck over here, thumbs up. Not so much, thumbs down. Check the playlist in the thumbnail on the screen right now, or the description box. Questions, comments, concerns, and requests can go in the comment section. And that's it. Bye for now. Adios.